de la construction. Et c'est Andrew Vaughan qui va nous en parler. Mr. Vaughan, please welcome on stage. Merci d'applaudir Monsieur Vaughan et de nous rejoindre sur scène. You also have 20 minutes. And please, this is your turn.
Bonjour tout le monde. Je suis désolé, mais I'm going to speak in English.
That's okay. Would you like a hand microphone?
Yeah, I'm a walker. Is that all right?
Let me give it to you. That would be easier.
Thank you.
You're more than welcome.
I can't. Is it working? Yeah.
Yeah.
Good. Thank you. Yeah, I'm a walker. So sorry, I'm going to speak in English. My French is appalling. So this is us. We're Waugh Thistleton. We are an architect's practice based in London, in East London, and we build entirely from timber.
Mr. Vaughan, I would need you to put it close to your chin.
Closer to my chin.
So then everybody can hear you.
Like a
just
lollipop.
like this. That's the trick.
And that's the other trick. Good. Okay, so we built our first CLT building in 2003, and we built a few more smaller ones, little houses here and there. But really, the ambition of our practice is to build high-density urban housing, to look at how we can build cities for the 21st century, healthy, happy, sustainable cities that don't have a terrible impact on the environment around them. So this building, Murray Grove, in 2008, completed, and still there, and everybody is happy. This building, I don't think it hadn't really been done before, so a lot of the details there we invented, and a lot of the kind of the way that the acoustics work, the way that the fire separation works, all these things we discovered as we and it was very much a process of research and of investigation. And you can see what we wanted to do was to keep it very simple. So keep all the details very simple. You know, we use the same thickness of walls all the way up the building, the same thickness of floors all the way up the building. You can see these little kind of connection details here, just 8 centimeter galvanized steel brackets with 10 centimeter screws. You know, incredibly simple process. So since we finished this building in 2008, we have built another 11 or 12, I think, buildings in cross-laminated timber. I'm not sure where I point this. I point at you. No, you?
Yeah.
Yes. So in 2016, we made a commitment to ourselves that we would, from now on, only build, research, investigate into timber and into timber construction. So we, in that year, 2016, we started on a project called Dalston Lane, which is a massive timber project, 16,000 square meters in central London on a very small, tight site. The building sits above a railway tunnel, and it's 10 stories high at its tallest point. And at this stage, we're really, I think, learning or getting a closer understanding of not only how to build in timber, but also what a timber architecture is beginning to look like, at least in London. Now, this building would have weighed over 10,000 tons in concrete. It would have taken 800 deliveries of concrete through the streets of London. But in fact, in timber, it weighs less than 2,000 tons, and we had 93 deliveries of timber. We saved 8 months by building in timber instead of concrete. And we built this building very quietly, right in the middle of London, very quietly, very accurately, and very quickly. I'm really struggling with this thing. 7,000 tons of CO2 are saved by building this building in timber. So, you know, the origin of our investigations, of our work into timber has always been about sustainability, about limiting the impact of architecture and construction on the environment. So using, I know you've heard loads of talks about this all day today, but, you know, using material that's replenishable, using material that you don't have to scrape off the top of the planet, but one that you can grow and will grow again. So what we're learning to do in the timber architecture is we're learning to use less timber. And you're learning to use less and less timber, probably not very popular for some of you here, but, and that really, because these buildings are so light, as we've been hearing about people having to put concrete on their buildings in order just to weigh them down. Because these buildings are so light, the battle that you always have is about wind load. So you're always resisting wind load. So what we're learning to do with this architecture is to build stout buildings, buildings like castles, more robust buildings. So you can see with this one here, we have two phases of the building. The one at the front is like, the one on the right is like Murray Grove, around a central core. The one on the left is more, has a core on each internal corner. So you get that kind of strength from the architecture in the plan. So no concrete necessary. Apart from on the ground floor, of course. So 121 homes, 4,000 square meters of business use. So that's about 800 people in the building altogether. So 10 stories, 34 meters tall, and we built the entire CLT structure in 5 months. 8 people in 5 months. It's just fantastic. And the other thing that we did with this building that we'd never done before was we went to competitive tender with the timber. So we've been doing this a while now, so we had a pretty good understanding, working with Rambo, our engineer, a pretty good understanding of what kind of sizes of timber we were going to use. So we did this drawing here between us, and you can see that in the top right-hand corner, we decided to go out to tender with KLH and Binderholz and Stora Enso. And what we did is we color-coded each one of the walls and each one of the floor slabs so that we could get an individual price from those 3 people, from those 3 companies. And that was a very successful process, and I think that it helped us all in terms of actually looking for even small innovations in terms of using less timber and building a quicker building. Oh. Back one. This one's good. So the other thing that we learned how to do as well was to, the building was very hard up against a neighboring building, and so what we had to do is prefabricate some of the wall systems. So we began to look, and we're looking more closely at this at the moment, in how we can prefabricate the entire wall system, including insulation, external, window, bring that to site, crane that into position, so no more scaffolding, etc. So this is us here about halfway through. You can see the scaffolding going up. The building is in a historical context in London within a heritage zone, so had to be clad in brick, which is kind of slightly counterintuitive, but anyway. I think here you can see how tight the site is, so just a small delivery area here, so the crane, the blue crane picking up the timber and then passing it to the yellow crane, which then lifting it into the right place. So as I was saying before, 5 months of construction. And this is us going up here by the train tracks. And there we go, on the right-hand side, finished. In fact, you can see how quick it was, because the train's still going past. So, so we're here, 800 people, 2,325 trees, which is just slightly less than 3 trees per person that lives there. So I don't think that's too much to ask, really, is it? 400,000 bricks, 1,400 tons of bricks. Took 14 months to lay the bricks, 5 months to build the structure. So you can see here, 800 people, I've said that. And here with the bricks here, you can see how, I mean, it's fantastic now. You know, the first time that we built a CLT building and we clad it in brickwork, we had to sort of invent special details. Now you go to a brick detailing magazine and they have a picture of how to build brickwork with CLT buildings. I mean, the nature of this has changed so incredibly. It's fantastic. And you know, this building as well, important to say, I think, that we didn't get this contract because of sustainability. We weren't awarded the instruction because of reducing the building's environmental impact. We proved this building on the basis of speed, quality, and cost efficiency. So you can see here a structural building. And again, I mean, referring to earlier speakers, I think that one of the beauties of working in CLT at this volume is that you're working with such a simple material, but one that can only exist with a very sophisticated process. So, you know, in our studio, we are completely BIM literate stage 2 BIM. We work very closely with engineers on producing finite element models, and then again with the panelization with the manufacturers. So that kind of process for us to be involved with the construction is really, to that degree, is really exciting. Because this drawing here is exactly how the building looks, which is rare in architecture. Feast your eyes on that. There you go. So this is the internal courtyard going up there, so 34 meters on the left. Yeah, if I stand in the right place, it works. So here we are. This is a photograph that we took last week, so everybody's in there. We went to meet our first residents last week, which is always really exciting, rewarding process. And you know, I can share experience. I myself live in a CLT building, so I can welcome them to our CLT living family and talk to them about the advantages, the wonderful things about living in a CLT home. So the fact that you can't hear your neighbors, that you don't need to use your central heating, that to cool the house all you need to do is just open a window. So these are really beautiful buildings to live in. I think that that's an essential part of an understanding of what it is that we're all trying to do as well, is not only to create an environmental architecture form of construction, but also to create beautiful buildings and create beautiful, healthy places to live. So we're doing this. We have, currently we've got 5 CLT buildings on site. We have 23 projects in timber in the office. We have 3 full-time research assistants in the office now. And one of the things that we're becoming increasingly fascinated about in terms of timber construction is actually how it's changing construction and looking at the nature of construction itself. So we have a really important kind of aspect of this around climate change, primarily around climate change, primarily around sustainability. And in the UK, we measure the carbon of a building for 60 years. So the lifespan of a building of 60 years, that's how we measure the carbon. And you can see, so if you build a building now, the carbon that you're getting to in 60 years, it means that operations are about 2/3, and the carbon footprint of the building materials, assuming a concrete building, is about 1/3. But actually, we don't have 60 years. If we keep doing this for 60 years, then we're in a lot of trouble. So even if you take it to the Paris Accords, to our zero carbon targets for the Paris Accords by 2035, then actually what we're looking at in terms of the building materials is in excess of 2/3 of the carbon footprint of the buildings that we're making comes just from the concrete and steel that goes into those buildings. And also looking at construction, as I was going a little while ago. So talking about construction, construction is the only industry where productivity has gone down in the last 100 years. So in the UK, we build buildings more expensively and slower than we did 100 years ago. You know, these buildings are priced opaquely. You know, nobody really knows how much concrete costs. It seems to go up with the wind. So looking at how we can actually begin to change the face of construction is becoming an increasingly important part of what we're doing as a practice. And that really is around modular housing. So we are currently working with 2 different companies on CLT modular housing. This one is a particularly big one in the north of England. The factory is 6.5 hectares big and will use about 110,000 cubic meters a year of CLT and produce 5,000 homes. So these 5,000 homes will be prefabricated in the factory, and that's completely prefabricated. So everything apart from the furniture, you know. So these houses will be delivered to site with the kitchens fitted, the bathrooms fitted. And what's really, I think, important or makes a kind of a shift change in this, in using CLT, is that when we put these big sheets through the CNC machine, when we cut these panels, every time you put the panel through the machine is the same process, and that's how factories work. But because it's a CNC machine, every time that panel goes through the CNC machine, we can cut it in a different way. So then we can begin to look at actually an architecture that's constructed from modular housing, which is not one of repeated boxes, but can actually be one that adapts to its context, that adapts to its use. So each one can be an individual piece of architecture. If only it was made of wood, then it would work. There you go. So these are prototypes here that we're beginning. So these are single-family houses. The other people that we're working with, we're doing a 7-story building with them as well from modular. And I just, when we started this journey of our practice over the last 14 years, this is a journey that really started about low-carbon buildings, about an understanding of working with a replenishable material. But as we have developed these ideas and understood that the buildings that we're making are healthy buildings, they're great for rural economies, people growing more trees. These buildings can be beautiful. They're firm, they're robust, they're functional and delightful places to live in and can create a delightful city. And what we've learned and what we're learning is about this repeatable process, so about the fact that actually what we can begin to do is to involve the people that we're building the houses for in the design and choice process. So much like with an Audi A4, where you have 1 million choices with an Audi A4, much like that we can begin to involve people in the houses that they live in. So no longer are we creating these white boxes with rather nice windows. The idea is actually we can begin to involve people in the customization and the introduction of choice. So what we see this as is not a race for this or that, but actually a construction revolution, a complete change in the way in which we build and design and inhabit our cities. And I've finished on this picture, which is the hand of Professor Schickhofer, and this is the number of seeds that it took to grow the trees that built Murray Grove. Thank you.
Thank you so much, Mr.